everybody. I'm Wang. I'm here to talk about validating your Argo workflows with validating webhooks. I think I've used the wrong slide template, and I don't have the purple and Argo on it, so we're off to a great start. But just a brief introduction. I'm Wang from Bloomberg, the workflow orchestration team. We offer a managed Argo workflow solution. We are a multi-cluster, multi-data center platform, meaning that we give our tenants a bunch of clusters across multiple data centers. So the problem statement here is that workflows submitted via the Kubernetes API server, they don't get validated by default. So usually there is this field in the CRD called Open API Schema or Open API. I can't remember the exact name of the field, but it does the regular schema validation for your custom resources. But in Argo, the installation uses a minimized CRD, which basically just put in some like not very useful schema in the CRD. That's because there's a limitation with the API server about the size of CRD. So as a result of that limitation, what will happen is that if you create a workflow with some bogus definition, so see in the spec, in templates it's a full bar, and if you create a workflow like that to the API server directly, you actually get accepted and created, so you get like 200 back. But then when you actually get the workflow in your cluster, you'll see that the workflow never actually executed. It just gives you an error message saying, "Oh, if I failed," and because there's an invalid spec in the definition. Ideally, we want to have this kind of invalid workflow catched before it actually makes it into the API server or into SCD. We want to actually be able to reject it right away when we execute kubectl create. So we just show that invalid workflows will get accepted by the API server, and adding a salt to injury, even if the workflow itself is a valid definition, so it checks out all the schema definitions, it might be referencing a workflow template that doesn't exist in the cluster. These will also not fail immediately when you create a workflow, but it will fail at a later stage when the workflow is executing. So both cause kind of a very annoying user experience when user create a workflow, they'll get a 200 back, but then later when they open up the Argo server UI and click into the workflow, they'll just see, okay, there's no node executed, just a big fat error message, I don't know what to do. So now backtrack a little bit, you might be wondering, why are you using the API server? There's Argo server, there's Argo CLI, both have this wonderful lint feature, why not just use those? Well, because we're a multi-cluster platform, we want to have a unified entry point to our clusters. We manage config maps and secrets in addition to workflows. We don't want to have to manage this mapping of, okay, you have a workflow, go to Argo server, but you have a config map, you need to use kubectl instead. For example, like for things like artifact ref or access keys for S3 and that kind of stuff. Using Kube API server as a unified entry point also makes integration with other systems such as Command and Open Cluster Management easier because they use, I think, work manifest, and they don't speak Argo at all. So that was the problem statement, and this is into the how we solved it part. Well, obviously we solved it with validating webhooks, it was in the title. But in case you're not familiar, validating webhooks are a part of the Kubernetes API server admission control. So when you create something via the API server, it goes through a list of steps. So LC, mutating webhooks, and then you will do this schema validation against the field that I mentioned at the start in the CRD, which is where the minimized installation of Argo is lacking. And then we basically do the validation at the stage right after schema validation in this validating and admission control. Basically, API server will call to our validating webhooks, and our validating webhooks will basically validate if the workflow is legit or the definition is legit, and then we will reject or accept it depending on the validation result. So more specifically, we use Kube Builder to bootstrap a validating admission webhook service. And under the hood, we actually just use the Argo validate function. So if you're not familiar, there's a file called validate.go in Argo codebase. This is actually what powers Argo lint and Argo server for validating a webhook, validating a workflow. And there's a lot of support for checking the workflow spec very thoroughly. So for example, you won't just check whether the schema definition, whether the workflow spec matches the schema definition. It will also go into each individual parameters for template invocation. You will check if all the required parameters are provided, and then you also verify if the template referenced in the Argo workflow actually exists, and many other things. And by calling this validate function instead of the Argo server, we actually drop the dependency on the Argo server deployment in the cluster. So basically, we don't have to have an Argo server in the cluster. We can always just invoke the function and do the same logic. So having this validating admission webhook basically allows us to validate all Argo resources submitted through all mediums. Like it could be from Argo server, Argo UI, it could be from Argo CLI or from kubectl. And then what this also does is that it makes this validation check implicit. So you wouldn't have to make a separate call to say Argo lint or kube create -- driver or something like that. It will always kick in. Every single submission will be validated, and if it's invalid, it will always get rejected. So as a result, we do not have any more invalid workflows accepted into our system. So all malformed workflows, so that full bar example I showed earlier, they'll just get rejected right away. And invalid workflow template references will also not be accepted because the validate function will check in and say, okay, this template does not exist. This workflow is not valid. You'll get rejected. And then we will not have any random workflows that fail in a later step that you don't get to see until you do a kubectl get. Every failure will be returned right away that relates to an invalid workflow definition. But obviously, there are some costs or caveats. So because validating webhook is a very critical step in the API server admission control, and it's a deployment, it may go offline for whatever reason. And if it does, it could basically either take your workflow submission offline. For example, it couldn't validate any workflow submissions, or depending on how you configure your validating webhook configuration, it could potentially take your whole cluster offline. So how to mitigate it? Well, just like with any other critical deployment, you make it highly available. You have more than one replicas. You set up telemetries, and then add proper retry handling at the top-level API, and so on and so forth. So all of that can help alleviate this kind of concern. And another problem we actually experienced was that these kind of validation functions can be very slow. So if you have a very big workflow definition, it could take a while for it to actually get validated. We gave our webhooks a very generous 30-second timeout. We haven't seen anything that's really slower than 20 seconds, I think. So your mileage may vary, but this is something you can increase the timeout if you are expecting really large workflows. And lastly, if you are installing this validating webhook into a cluster that already has workflow templates in it, you might want to make sure that all your workflow templates in the cluster is valid before you turn on the validating webhook, because the Argo lint function or the validate function will actually go look for all the template referenced in the workflow. And if it found an invalid template, it might have trouble with decoding and have your validating functions fail in unexpected ways. So that's it for a rundown of our solution to solving validating workflows. And or hiring. So if you're interested. If the QR code is not big enough, there's a bigger one. So thank you.